Okay, so welcome back, everyone. Last time I promised that we would cover truck and shovel production calculations, and that's what we're going to do here today for the surface mining course here at Bluefield State University. So let's jump right on into it. When determining the number and size of shovels or excavators, you have to consider the following 12 parameters, okay? That's the ground bearing pressure, the size of the truck, the bench height, the tonnage that's required, whether or not you have to blend your materials, the number of pits and faces, the fragmentation that's expected, like how good your fragmentation is, what maintenance facilities you have, material weights, how much does it have to pick up, pit geometry, the dipper weight that's required, and infrastructure requirements. I know we've talked briefly on this in the past, but these are very heavy pieces of equipment, very heavy trucks. You have to have good roads. You have to, and have good other forms of infrastructure as well. So you have to keep all that in mind, because there's not just a specific equation for determining the size of the shovel you need. You have to take all of this into account and design it based on production requirements, right? So you can design your shovel based on the production requirements. Like I said, it does still have to fit in the space that you're working. It has to load the proper size trucks that can run on the roads that you have. But this equation comes out of the SME Mining Reference Handbook. We're going to try to get some copies of those as well, of this book, because this is very important for just a reference to have forever, okay? This is what you use when you're taking the PE exam. It's what you're allowed to take or have with you during the test. It's electronic. So anyways, that's what we're using here. And to get the loading production in cubic yards, bank cubic yards per hour, you multiply the bucket capacity, the heaped capacity, which is in loose yards, the swell factor, which is the ratio to bank to loose yards, the operating efficiency, the fill factor of the bucket, propel time, and the load cycle time. The following four charts are used in conjunction with those previous equations, and this gives you average cycle times for different digging, with also average fill factors, okay? We have bench and swing angle corrections, if you need those, and then the operating efficiencies are here as well. So I know we touched on some of these in the previous lecture, but I'm just hitting those again. And then finally, the fourth chart is that propel time factor. So for strip mines, that's a 0.75, and that's what we're going to be using in the example that's to follow. So we have a practice problem here, and a mine operator is proposing a contour surface mine in central Appalachia. Excavation will take place with a 20 cubic yard excavator. Assuming medium hard digging conditions are encountered, the bucket fill factor is the average value associated with these conditions. Assuming that management is good, but that the site or job conditions are only fair. Assume that the swell factor of the overburn to be removed is 20%, and that the cycle time of loading a single bucket is half a minute. A nice good average. So we just use the equation that we had, right? There's 3,600 seconds per hour. That's a conversion factor. The bucket capacity is 20 loose cubic yards. Our swell factor is 1.2. Efficiency is 0.69. Fill factor is 0.825. And PT is 0.75. So we multiply all those together, and then we divide by our cycle time, which is 30 seconds, and we get 1,229 bank cubic yards per hour. So that's the production rate of the shovel, how much overburden it can remove in an hour of operating. So, given that we have a 20 cubic yard bucket capacity, what truck capacity is required for a 4-pass match? If you remember last time I said that typically trucks are loaded within 3 to 5 passes. I've read that that's a little bit different than what I was taught, and it's now 3 to 6 passes. So in the middle of that range, 4 or 5 is a good number to be at. Okay, so what we call a pass match though says what size truck do you need that is loaded in exactly 4 passes. So we know that these trucks are loaded with huge cubic yards, right? So we have 80 loose cubic yards. That's 4 loads from a 20-yard bucket. And we divide that by the swell factor, and that becomes 66.7 bank cubic yards. So now that we know the in-place yardage, we can take an average 160 pounds per cubic foot for the weight of the overburden, and then convert that by multiplying by 27, right, cubic feet per bank yard. And then we divide that by 2,000 pounds per ton to get 144 tons, okay? But we've got to remember the bucket fill factor, right? It's not quite all the way full. And so if we use that same 0.825, we then get 118 tons. And this is somewhere between a Cat 777 and a 785. So it's a little bit in between. Fortunately, manufacturers, this is Cat specifically, they give you the optimized pass match for each of their shovels and their wheel loaders too. Some of them at least. So what size trucks you can load with those is here in this chart. So now let's assume that we're loading 785s. We're only loading with 4 passes though, because we don't want to overload our 777s. So how long does it take? How many trucks do we need? And to figure that out, we have to take into account the haulage cycle time. And that theoretical cycle time is how long it takes to load the equipment, plus the travel time to the dump point, so the loaded travel time, the dump time, like how long it takes to dump, and then you have the return time, which is unloaded and probably a bit faster, a corrected haulage cycle time, which is then equal to taking into account the wait time and the delay time. Okay, so here we go. So how do we calculate the travel time, right? So that's relatively simple. It's just the distance divided by the average speed, right? And then there's a conversion factor for converting the units, whether or not you're using feet, English or a metric. So that gives us the travel time. So let's do some more practice problem. Given the equipment we've discussed in the following details, how many trucks do we need? So a fleet of trucks is required to operate the 20 cubic yard shovel previously discussed. And the following information was provided by a previously conducted time study. Okay? And so we have the load cycle time per pass, half a minute. Spot time, half a minute. Dump time, 1 minute. Loaded haul run, 8 minutes. And the return empty, 6 minutes. So for this, we are going to assume that the availability is 100%, and that there's no delays involved. You can involve whatever delays you would like. Generally speaking, there will be a dozer, especially if you have a large electric rope shovel that will clean up around the shovel, and that's because it can dig big material, but it doesn't do a very good job of cleaning around it. So they use some sort of dozer for that. And the cases that I'm familiar with, we used a wheeled dozer, and it worked great. But we're going to assume that those are 0 for now. And so the total cycle time is then calculated as the sum of those individual components. So we have half a minute times 4 passes, plus the half a minute, plus a minute, plus 8 minutes, plus 6 minutes. And that gives us a total cycle time for one truck to get loaded and get back 17 and a half minutes. So then the number of trucks is the total cycle time divided by the load plus spot time. Okay, so we have 17 and a half minutes, and we divide that by half a minute times 4 passes plus the half minute for spotting, right? So how long it takes to back up. And that gives us 17 and a half minutes divided by 2.5, right? Because that's how long it takes to load a truck. With that, you need 7 trucks in this system. So that's how you calculate that. And you can see that if you were given, examples in distance and speed, right? Like if they got to haul 5 miles and their average speed's 40 miles an hour, you could easily calculate the time it takes to make those trips as well. So depending on how you're given the information, you can come up with the same answer with relative ease and unit conversions and times and that sort of thing. So with that is completed truck shovel calculation, and that is going to complete our sort of basic overview of surface mine equipment and sizing and that sort of thing. So with that, we'll see you next time. Have a great one.